Hello guys, my name is Craig and welcome to Premier Solutions. In today's video, we're going to talk about how we calculate the Scalar product. But before we start, please make sure that if you're new to my channel, you hit the subscribe button and turn on the notification bell so that you don't miss out on any new videos. So to start off, the scalar product, right? Say a scalar product of two vectors A and B is written as A dot B, and this is sometimes called the dot product, right? So this A dot B, which is the scalar product, is given by the magnitude of A multiplied by the magnitude of B, then multiplied by cos theta, whereby theta is the angle between the vectors A and B, right? But this method is not so convenient because in most situations we don't know theta, right? But we can come up with another way of calculating the scalar product, right? So say vector A is A1, A2, A3, right? Then vector B is B1, B2, B3. A dot B will be given by A1, B1 plus A2, B2 plus A3, B3. So this is another way of calculating the scalar product. We're just multiplying the corresponding values in the corresponding directions. To say in the x direction we've got A1 times B1, then plus in the y direction we've got A2 times B2, then plus in the z direction we've got A3 times B3. Right. So now that we've come up with this formula, we can now derive a formula for calculating theta, right? So now if we say magnitude of A times magnitude of B cos theta is equal to A1 B1 plus A2 B2 plus A3 B3. This implies that cos theta would be now given by A1 B1 plus A2 B2 plus A3 B3 all over magnitude of A times magnitude of B. Right. So we've got this formula for calculating theta, this one for calculating the scalar product. Right. And there's a special situation. Right. Now when the scalar product A1 B1 plus A2 B2 plus A3 B3 is equal to 0. Right? When this is equal to 0, this definitely means that cos theta is equal to 0. Then theta would be equal to 90 degrees. Right? So this is a very important statement. Right? And this implies that when the scalar product is equal to 0, this implies that vector A is perpendicular to vector B. Right? So vector A is perpendicular to vector B when the scalar product is equal to 0. So when A dot B is equal to 0, then A is perpendicular, right? Perpendicular to B, right? So this is a very important result and we shall use it. So now let's jump in to look at the questions. So allow me to erase just the last part. Right, so let me probably rewrite it here. When A dot B is equal to 0, we're saying A is perpendicular to B. Right. So now for number 1, we're asked to calculate the angle between the following pairs of vectors. We've got I plus J plus K and I plus 3J plus 2K. Right, so using this formula here, we're saying that cos theta, okay, so for A, we're saying cos theta is equal to A1 B1, we're saying 1 times 1, that's a 1, then plus 1 times 3, that's a 3, then plus 1 times 2, that's 2, over the square root of 1 squared plus 1 squared plus 1 squared, which is root 3, root 3, in times square root of 1 squared, that's 1, plus 3 squared, that's 1 plus 9, which will give us a 10. then plus 2 squared, which is plus 4, which will give us a 14. Okay, so here we'll get a 6 over root of 42, like that. 42. And then now we can say theta shall be arc cos of 6 over root 42, which will give us, quickly get my calculator. So arc cos of 6 over root of 42, that will give us 22.2 degrees. So 22.2 degrees is the angle for the first part. Then for the second part, part B, we're saying cos theta is equal to 1 times 6, that's a 6, plus 2 times minus 1, that's a minus 2, right? Then plus 3 times minus 2, that's minus 6, over root of 1 squared plus 2 squared plus 3 squared, that's 1 plus 4 plus 9, which will give us 14, then times root of 6 squared plus minus 1 squared plus minus 2 squared, that's 36 plus 1 plus 4, which will give us 41. Right, and this would be equal to 6 minus 6 gives 0, so minus 2 over root 14 times 41, like this. Then theta would be arc cos of minus 2 over root of 14 times 41. And this would be equal to arc cos of minus 2 over root 14 times 41. That will give us 94.8. So this will be 94.8 degrees to 1 decimal place, of course, right? So this was looking at number 1. Then now we shall move on to look at number 2. Right, so allow me to erase this part. Okay, so for number 2 says find the value of P for which the vectors I minus 2j plus k and 3i plus 4j plus pk are perpendicular to each other. So now we are back at this result. We said when the scalar product is equal to 0, then the two vectors are perpendicular. So now if these two vectors are perpendicular, this implies that their scalar product should be equal to 0. So we're saying 1 times 3 for the i's, then minus 2 times 4 for the j's, plus 1 times p for the k's. This should give us 0. This is number 2. So 3 minus 8 plus p is equal to 0. And p is simply equal to 5. So p is equal to 5. As simple as that. Then now moving on to number 3. Number 3 says, show that the lines r is equal to 214 plus t 362 and r is equal to 7213 plus lambda 2 minus 10 are perpendicular and skew. Right. So if they are perpendicular, the scalar product of their direction vectors should give us 0. Right. So 362 dot 2 minus 10 should give us 0. So I say 3 times 2, that's a 6. Then plus 6 times minus 1, that's minus 6. Plus 2 times 0, that's a plus 0, which gives us a 0. So now, scalar product being equal to 0, these two lines are perpendicular. And now to prove that these two lines are skew, right, we shall have to calculate values for t and lambda, such that the position vector that we get here is different from the position vector that we get there. Right. So we're saying 2 plus 3t, 1 plus 6t, 4 plus 2t, right, is equal to 7 plus 2 lambda, and then 21 minus lambda, and 3, like this. Then we equate. So we can first of all solve for t. T is the simplest. 4 plus 2t is equal to 3, which implies that t is equal to 1 over 2. Sorry, minus 1 over 2 actually, because it's 3 minus 4 over 2, which is minus half. So t is equal to minus half. Then solving for lambda, we're saying 1 plus 6 over minus half should give us 21 minus lambda. Right, then this is minus 3. So 1 minus 3, that will be minus 2 is equal to 21 minus lambda. And lambda is equal to 23. Like this. So if we substitute the values for lambda and t, we should get different values here. So substituting for t first, by saying 2 minus 3 over 2, that's 2 minus a half, 2 minus 1 and a half, which should give us half, right? Then 1 plus 6t, right? So 6 times minus half, that's minus 3, 1 minus 3, it's minus 2, right? And then 2 times t, that's minus 1, 4 minus 1, that's a 3, right? So this being equated to, for lambda 23, by saying 7 plus 23 times 2, that's 46. 46 plus 7, that's 53. And then 21 minus 23, it's minus 2, and got a 3 there. So as you can see, you've got 3 minus 2 minus 2, but half is not equal to 53. So these two lines, they don't intersect, they're not parallel, they don't have a common point, therefore they are skew and perpendicular. Okay, so this was looking at how we would find the scalar product and simply apply a bit of basics to the questions. So please feel free to leave a comment, drop a like, and don't forget to subscribe.